Good morning, everyone. Welcome to NMK 444030, Engineering Technologist in Society. I'm glad to have you all here today. Today's lecture focuses on a topic that sits right at the heart of what it means to be a responsible professional engineer: occupational safety and health, or OSH, in the workplace. Now, I want you to think about something for a moment. Every piece of infrastructure you will ever design, every system you will ever build, every machine you will ever commission, all of it will eventually be operated by a human being. And that human being has a family waiting for them at home. The question we need to ask ourselves, not just as engineers, but as human beings, is, have we done everything we can to make sure they get home safely? That is the fundamental question behind every concept we will cover today. OSHA is not a checkbox. It is not a bureaucratic exercise. It is a professional and moral commitment. And by the end of this lecture, I want you to understand not just what the rules are, but why they exist and what happens when they are ignored. Let's begin.
Before we dive in, let me walk you through what we'll be covering today so you can see how the pieces fit together. We'll start with the basics. What is a safety and health program? Then we'll look at Malaysia's journey to where we are today, tracing our safety legislation all the way back to 1890. After that, we'll examine the statistics, because numbers tell a story, and the numbers in Malaysia are alarming. We'll then ask the fundamental question: why should we manage OSH at all? Is it just because the law says so? We'll see that it goes much deeper than that. There's a moral dimension, a legal dimension, and a surprisingly compelling financial argument. From there, we'll look at the legal framework in detail, OSHA 1994 and its 2022 amendments, which came into full effect in June 2024. We'll close with real-world case studies that show what good OSH practice actually looks like in practice, and what catastrophic failure looks like. By the end, you will have a complete mental framework for understanding why safety is not optional. It is the structural foundation of professional engineering.
Let's start with the fundamentals. What exactly is a workplace safety and health program? At its core, it is a systematic plan with 3 objectives: to identify hazards, to control risks, and to respond to emergencies. And the key word here is systematic. This is not something you do once and forget. It is an ongoing, structured process that must be embedded into every aspect of how work is done. Think of it like a hospital's infection control protocol. A hospital doesn't wait for patients to get sick before it thinks about hygiene. It builds sterilization procedures into every routine. Safety management is the same philosophy applied to the workplace. The 3 pillars are identify, control, and respond. Identify means proactively recognizing all potential hazards in your work environment, not just the obvious ones, but the subtle ones. The wet floor that no one put a sign on. The poorly ventilated room where chemicals are being handled. The ergonomic strain from 8 hours at a badly positioned workstation. Control means you then put measures in place to manage those risks. You don't just observe them, you act on them. And the nature of that action matters enormously, as we'll see later when we discuss the hierarchy of controls. Respond means you have emergency plans ready before an incident happens, not after. If you're writing the emergency procedure on the day of the accident, it's too late. This 3-part framework is the foundation of everything else we'll cover today.
Now let's place all of this in a Malaysian historical context. Because our current laws didn't appear from nowhere, they evolved in response to real tragedies, real deaths, and real failures of the system that existed before. Malaysia's first safety legislation dates back to 1890. The boiler enactment was introduced primarily for the tin mining industry in Perak, a sector that was booming at the time and where boiler explosions were a genuine and recurring danger. Then came the Factories Act of 1967, which broadened coverage to factory workplaces generally. But here's the critical gap: it only covered factories. Agriculture workers, construction workers, public sector employees, they were largely left unprotected. The real turning point came in 1991. On the 25th of May, an explosion and fire at the Bright Sparklers Fireworks factory in Sungai Bulu killed 22 workers. It was a horrifying tragedy, and it sent shockwaves through Malaysian society. People demanded to know, why weren't these workers protected? What kind of system allows this to happen? That public outrage, combined with lessons learned from the 1984 Bhopal gas disaster in India, which we'll look at in detail later, catalyzed the creation of the Occupational Safety and Health Act in 1994. OSHA 1994 was a landmark piece of legislation. For the first time, it provided comprehensive protection for workers across almost all economic sectors. And the journey didn't stop there. In 2022, OSHA was significantly amended, with those amendments coming into full legal effect on the 1st of June, 2024. The lesson from this timeline is clear. Safety law in Malaysia was written in blood. And that makes it even more important that we understand it and respect it.
So, why should we manage safety and health? Let me give you 3 compelling answers. The first is legal obligation. Under OSHA 1994, every employer is legally required to ensure the safety, health, and welfare of their employees at work, as far as is practicable. The Factories and Machinery Act 1967 also imposes specific requirements. If you fail to comply, you face penalties. Since the 2022 amendments came into force in 2024, those penalties have become dramatically more severe, up to 500,000 ringgit in fines, and directors can face personal liability. We'll look at the numbers in detail shortly. The second reason is moral and ethical duty. As engineers, we operate under a code of ethics governed by the Board of Engineers Malaysia, or BM. The BM code has 5 sections, and the paramount principle is this: a registered engineer shall at all times hold the safety, health, and welfare of the public above all other considerations. This overrides employer instructions. It overrides client contracts. Public safety comes first, full stop. The third reason is financial sense. This one often surprises people, but it is actually the most persuasive argument in a corporate boardroom. The financial cost of accidents is enormous. Direct costs, medical bills, compensation payments, equipment repair are just the beginning. But research consistently shows that indirect costs, lost productivity, worker replacement, investigation time, damage to company reputation are 4 to 10 times greater than the direct costs. Every ringgit you don't spend on safety today could cost you 10 ringgits tomorrow. The bottom line, managing OSHA is not a burden. It is an investment with one of the highest returns in business.
Let's now get into the specifics of what OSHA 1994 actually requires from employers. Because ignorance of the law is not a defense, especially with the penalties now in play. Under OSHA, employers have 6 core duties. First, safe systems. You must maintain safe plant equipment and work systems. This is not optional. If a machine is dangerous, you have a legal duty to fix it, guard it, or decommission it. Second, safety policy. If you employ more than 5 workers, you must formulate a written safety and health policy and communicate it to your employees. It must be more than a document in a filing cabinet. Your workers need to know about it. Third, safety officer. For high-risk workplaces with more than 100 employees, you must hire a certified safety and health officer, someone with formal training and accreditation. Fourth, safety committee. If you employ 40 or more workers, you must establish a safety and health committee. This is a formal body that meets regularly to review safety practices, investigate incidents, and make recommendations. Fifth, report incidents. Any serious accident, dangerous occurrence, or occupational disease must be reported to the Department of Occupational Safety and Health, DOSH. Failure to report is itself a criminal offense. Sixth, and this is often overlooked, employee duties. Under OSHA, employees also have responsibilities. They must wear PPE when required, follow safety instructions, and cooperate with their employer's safety program. Safety is not a one-way obligation. The threshold requirements are particularly important to remember. More than 5 employees triggers the safety policy requirement. 40 or more triggers the committee requirement, and over 100 in high-risk sectors triggers the certified safety officer requirement. I want to spend a moment on the financial argument for safety because I think it is genuinely underappreciated. Most people, when they think about the cost of a workplace accident, think about the visible costs. The ambulance, the hospital bill, the compensation payout. These are the direct costs, and they are real and significant. But here is what most people don't realize. The indirect costs, the hidden costs below the surface, are 4 to 10 times greater than the direct costs. Let me explain what those indirect costs look like. When a worker is injured, you need to find a replacement. You need to train that replacement. The replacement will inevitably be less productive than the experienced worker they replaced, at least initially. Then there's the management time spent investigating the incident and filling in reports. There's the impact on the morale of the surviving team. Nothing disrupts a workforce like watching a colleague get seriously hurt. And there's the reputational damage. If your company becomes known as an unsafe place to work, talented engineers won't want to join you, and clients won't want to hire you. The ILO, the International Labor Organization, estimates that poor occupational safety and health globally costs around 4% of world GDP every year. Think about what that means in real terms. Now here's the flip side. Every dollar genuinely invested in a strong OSH program, proper hazard identification, good engineering controls, well-trained workers, pays back multiple times over in reduced accidents, reduced downtime, lower insurance premiums, and higher productivity. Prevention is always better and cheaper than cure. This is not a moral argument. It is an economic fact.
Building on that financial case, let me summarize the concrete benefits that organizations with strong OSH programs consistently experience. Reduced insurance premiums. Insurers reward safety-conscious organizations with lower premiums because they represent lower risk. This is a direct, measurable cost saving. Fewer compensation claims. When accidents don't happen, there's nothing to compensate. SOCSO, the Social Security Organization, reports billions of ringgit in annual payouts. Organizations that invest in prevention avoid contributing to that pool. Improved employee morale. Workers who feel safe and valued are more engaged, more productive, and more loyal. They take fewer sick days and they stay longer. In a competitive labor market, this matters enormously. Less production downtime. Every serious accident disrupts operations, sometimes for days or weeks. Equipment gets taken out of service. Workers are sent home. Investigations are conducted. Strong OSH programs mean fewer disruptions. Reduced legal risk. As I mentioned earlier, the penalties under the 2022 OSHA amendments are severe. Staying compliant keeps you out of court and keeps your directors out of jail. Better company image. Customers, investors, and prospective employees all pay attention to safety records. A company known for its safety culture attracts better talent and better business. The case studies from the UK support this. NHS Trust achieved a 16% reduction in incidents. British Sugar cut lost time injuries by 43%. Sainsbury's reduced reportable incidents by 28%. These are not small numbers. They represent real money and, more importantly, real lives.
Before we go any further, I need to make sure we're all speaking the same language. In safety management, precision of language is critical. Misusing these terms in a safety report or a legal document can have serious consequences. Let's go through 5 key definitions. Hazard is any condition, substance, activity,
or situation that has the potential to cause injury, disease, or damage. Notice the word potential. A hazard is static. It exists regardless of whether anyone is exposed to it. A bottle of concentrated acid sitting on a shelf is a hazard. It hasn't hurt anyone yet, but the potential is there. Risk is the probability that harm will actually occur as a result of exposure to that hazard. The formula is simple. Risk equals likelihood multiplied by consequence. A high-severity hazard with a low probability of exposure produces a moderate risk. The same hazard with daily exposure and no controls produces a very high risk. Danger is the relative level of exposure to a hazard. You can have a hazard present, but danger can be low if proper precautions and controls are in place. Danger is dynamic. It changes based on the control measures you implement. Safety is relative freedom from hazard. I want to emphasize the word relative. Absolute safety is a theoretical concept. It doesn't exist in practice. There will always be some residual risk. Safety management is about reducing that risk to an acceptable level. Accident is an unexpected chain of events resulting in injury or damage. Crucially, this definition includes near misses, events where injury could have occurred but didn't purely by chance. Near misses are incredibly valuable safety intelligence. Every near miss is a warning that should be investigated and acted upon. Make sure you can use these terms correctly in an examination, in a professional report, and in your daily engineering practice.
We've covered a lot of ground today, so let me bring it all together with 5 core takeaways that I want you to carry with you beyond this lecture. First, OSH is mandatory by law. The Occupational Safety and Health Act 1994, as amended in 2022 and fully enforced from June 2024, is not optional. It applies to all workplaces, offices, factories, construction sites, public sector institutions, and even work-from-home environments. Ignorance is not a defense. Second, engineers have moral, legal, and financial obligations to ensure workplace safety. These 3 dimensions reinforce each other. Moral failure becomes legal violation, which guarantees financial loss. You cannot separate them. Third, indirect accident costs are 4 to 10 times greater than direct costs. When you're tempted to cut the safety budget, remember this number. What you save today in prevention costs could multiply by 10 in accident costs tomorrow. Fourth, good OSH programs reduce insurance costs, operational downtime, and legal risk. This is not just about avoiding bad outcomes, it is about creating a positive, productive work environment that attracts talent and builds organizational resilience. Fifth, and most fundamentally, prevention is always better and cheaper than cure. This is the philosophical cornerstone of modern OSH management. The shift from reactive to proactive, from correcting hazards after accidents to eliminating them before they cause harm, is the defining characteristic of a mature safety culture. In your career as an engineer, there will come moments where safety concerns conflict with project timelines, budget pressures, or client demands. When that happens, I want you to remember today's lecture. You have the knowledge, the professional obligation, and the legal backing to prioritize safety. Use it. Thank you. We'll now open for questions.
Let me bring this closer to home, literally. This is a real incident that happened right here at Unimap on the 17th of September, 2012. A fire broke out in an electrical distribution board. The incident was discovered by a security guard on duty, who immediately notified the safety department. The fire and rescue department had to be called in to extinguish the blaze. Estimated loss to the university, RM 15,000. Now, what caused it? The initial investigation found 2 root causes. First, electrical overload. The system was drawing more current than it was designed to handle. Second, and more troubling, unauthorized wiring modifications had been made to the system by the development department without obtaining proper authorization from the relevant authority. This is a classic case of what happens when someone decides to bypass the system, just this once because it seems easier or faster. Someone needed more power for a project. Rather than going through the proper process, submitting a request, having it reviewed by a qualified engineer, getting the work done safely, they made the modification themselves. Or they instructed someone else to. And the result was a fire. The slide also notes something important. When the fire alarm sounded, building occupants were slow to respond to the safety instructions from the security department. This tells us that even when the physical safety system works, behavioral compliance can be the weak link. What are the engineering lessons? First, never modify electrical systems without authorization from a qualified professional. Second, any modification must be properly documented and inspected. Third, if your electrical load is growing, you must do a proper load analysis and upgrade the infrastructure through the correct process. And fourth, emergency response drills must be conducted regularly so that when the real event happens, people react immediately and correctly. This is not just a historical curiosity. This is the kind of incident you could encounter or cause in your own engineering career. The principles are universal.
Now, I want to take you to the other end of the severity spectrum. What happens when an industrial safety system doesn't just fail in one place, but fails simultaneously across every layer of protection? On the 3rd of December, 1984, in Bhopal, India, approximately 40 tons of methyl isocyanate, a highly toxic chemical used in pesticide manufacturing, leaked from a Union Carbide plant. Within hours, over 3,000 people were dead. 50,000 suffered permanent disabilities. The surrounding residential areas were completely unprepared for an event of this magnitude. When investigators examined what happened, they found that not one, not two, but 4 separate safety systems had all failed simultaneously. Barrier 1, the protective equipment on the storage tank designed to halt the initial chemical reaction, was not in working order. Barrier 2, the refrigeration system that should have kept the chemical storage tank cool, had been shut down to save costs. Barrier 3, the scrubbing system designed to absorb any escaping toxic vapor, was unavailable at the time of the incident. Barrier 4, the flare system, designed to burn off any vapor that bypassed the scrubber, was out of order. Every single fail-safe had been disabled or neglected, and the investigation revealed why. The parent company had made a deliberate decision to apply looser safety standards at the Bhopal facility than at comparable facilities in the United States because the regulatory environment in India permitted it. The Supreme Court of India ultimately ordered $470 million in compensation, a landmark ruling that established that choosing a location specifically to bypass stricter safety standards constitutes criminal negligence. The lesson for you as future engineers is profound. The phrase, "it doesn't need to meet the same standard because it's in a different jurisdiction," is not an ethical justification. Hazards are physical realities. They don't care about borders. The acid burns just as badly whether you're in Bhopal or in Penang. Safety standards exist to protect human beings, not to satisfy regulatory checklists. And if you are ever in a professional situation where you are asked to apply lower standards than you know to be safe, you have an ethical and legal obligation to refuse.
This slide visualizes one of the most important conceptual models in OSH management, the iceberg model of accident costs. Look at the iceberg. What is visible above the water line? The direct costs, medical and compensation payments, the cost of repairing or replacing damaged machinery, payments for work time lost by the injured worker. These are the costs that appear in incident reports. These are the costs that managers argue about. These are the costs that people use to justify decisions. And they represent just the tip of the iceberg. Below the waterline, invisible, but vastly larger, are the indirect costs. Replacing and retraining a new worker. The reduced output of that new worker while they get up to speed. Management and supervisory time spent on the investigation and on preparing reports. The negative impact on the morale of the remaining team, colleagues who witnessed the accident, who are now anxious, distracted, or grieving. Poor public relations, particularly if the accident becomes news. And, perhaps most importantly and most difficult to quantify, the unquantifiable human suffering of the injured worker's family. These indirect costs, according to research, are 4 to 10 times greater than the direct costs. Now, here's the critical insight this model gives us. If management only sees the visible tip, the direct costs, they will consistently underinvest in prevention. They see a RM $50,000 compensation payout, and they think that's the total cost of the accident. But the actual total cost, once you account for everything below the waterline, might be RM $300,000 or RM $500,000. The moment a manager truly internalizes the iceberg model, the financial case for OSH investment becomes irrefutable. You are not spending money on safety. You are avoiding an iceberg.
We've talked about 3 reasons to manage safety. Now, let me show you how they interlock in a way that makes each one reinforce the others. The 3 pillars are moral and ethical, legal and financial. And I want to emphasize, these are not 3 separate arguments. They are 3 dimensions of the same reality. The moral and ethical pillar is about respecting the people who come to work every day. These are human beings with families, with aspirations, with the fundamental right to return home safely. As engineers, our professional code, BM Circular 3/2005, explicitly states that a registered engineer shall at all times hold paramount the safety, health, and welfare of the public. This is not a suggestion. It supersedes our employer contracts and our client obligations. Public safety is our highest professional duty. The legal pillar means compliance with the Factories and Machinery Act 1967, now largely absorbed into the updated OSHA framework, and the OSHA Act 1994 with its 2022 amendments. Under the modern framework, employers bear primary responsibility for the practicable safety of the workplace. The shift from government enforcement to self-regulation means you cannot wait for an inspector to tell you what's wrong. You must proactively identify and manage your own risks. The financial pillar shows that OSH is not just an obligation. It is economically rational. Preventing accidents avoids the massive indirect losses we've discussed. It keeps insurance premiums down. And research shows that well-implemented behavioral safety programs can generate an ROI of up to 281%. You read that correctly. 281% return on investment. When a safety decision aligns with all 3 pillars simultaneously, as good safety decisions always do, you know you're on the right track.
Let me now give you a more detailed timeline of how Malaysian safety law evolved, because each milestone reflects a lesson learned, often painfully. 1890, the Boiler Enactment. This was Malaysia's very first safety legislation, and it was narrow in scope, mandatory boiler inspections specifically for the tin mining industry in Perak. The focus was entirely on machinery. There was no concept of worker rights or broader hazard management. 1913 and 1932 machinery enactments. These expanded scope to include broader machinery safety regulations and installation registration requirements. Still focused on equipment rather than people or systems. 1953, the Machinery Ordinance. This superseded the earlier regulations with more comprehensive rules, now enforced by the Ministry of Labor. Progress, but still limited to specific machinery. 1967, the Factory and Machinery Act. This was a significant leap forward. It covered safety and health in factories, but it still left critical gaps. Workers in agriculture, construction, and public services were largely unprotected. 1991, the Bright Sparklers explosion. As we discussed, 22 workers killed in Sangay Bulu. Public outrage, demands for stiffer penalties and broader protections. 1994, OSHA, universal protection across most economic sectors. A fundamental philosophical shift from prescriptive government enforcement to self-regulation by industry. 2024, the integration. On June 1st, 2024, the FMA 1967 was officially repealed. Its technical machinery regulations were absorbed into the modernized OSHA framework. Malaysia now operates under a single, unified occupational safety law for the first time. Each step in this timeline represents the accumulated wisdom and the accumulated cost of generations of workers before you. Study this history and understand its weight.
Now I want to walk you through how accidents actually happen. Because accidents don't come out of nowhere, they follow a predictable chain of events. And if you understand the chain, you can break it at multiple points. The flow is hazard exposure interaction risk uncontrolled state accident harm. Let's walk through this step by step. It starts with a hazard, a condition with the potential to cause injury, disease, or damage to equipment or the environment. A circular saw, a chemical storage tank, a wet floor, a poorly guarded machine. Then comes exposure or interaction. The hazard by itself is dormant. It only becomes dangerous when a person or property comes into contact with it. A worker using the circular saw without a blade guard is now in the exposure zone. From exposure, we arrive at risk, the possibility of an adverse effect occurring. Risk is not a fixed number. It depends on the likelihood of the exposure and the severity of the potential harm. If the risk is uncontrolled, if no measures are in place to reduce the likelihood or severity, we reach an uncontrolled state. And from an uncontrolled state, the accident and harm are likely. Here's the key insight from this diagram. There are multiple intervention points. You can remove the hazard entirely. You can reduce exposure. You can implement controls to reduce likelihood or severity. The more intervention points you address, the more layers of protection you build. And I want you to notice this important footnote from the slide. Workers don't create hazards. They are often built into the workplace design. This is a profound shift in how we think about safety. When accidents happen, the instinct is often to blame the individual worker. But the research consistently shows that most accidents are the result of system design failures, decisions made at the design and management level, not the operational level. This means that as engineers and designers, you carry a greater burden of responsibility than you might have realized.
This is one of the most important slides in the entire lecture because it directly affects you as a future engineering professional in Malaysia. The 2022 OSHA amendments, which became active law on June 1, 2024, have dramatically changed the risk landscape for employers and managers. Let me walk you through the 4 key changes because the contrast between old and new is stark. Applicability. Previously, OSHA was limited to specific sectors listed in its first schedule. Construction, agriculture, public sector employees, many were excluded. From June 2024, OSHA applies universally to all places of work in Malaysia, including the public sector. If you work there, OSHA applies. No exceptions. Maximum penalties. This is the number that gets boardroom attention. The old maximum fine was Rm 50,000. The new maximum fine is Rm 500,000, a 10-fold increase. And crucially, directors now face joint and several liability. This means that if a company is found guilty of an OSHA violation, individual directors can be prosecuted personally, not just the company as a legal entity. Your personal assets are now at risk. Employee rights. Under the old system, there was no explicit statutory right for workers to refuse dangerous work. Section 26A of the new amendments grants employees the explicit statutory right to remove themselves from a situation of imminent danger without penalty. This is a fundamental expansion of worker rights, and it is directly modeled on lessons learned from tragedies like Bhopal. Personnel mandates. Previously, only large or high-risk sites were required to have certified safety and health officers. Now, under Section 29A, even small businesses with 5 or more employees that don't qualify for a full SHO must appoint a certified OSH coordinator. Failure to comply, RM 50,000 fine. The message is clear. The era of treating OSH as optional or as something only big companies need to worry about is over.
Now let's introduce one of the most important practical tools in Malaysian OSH practice, HIRARC. HIRARC stands for Hazard Identification, Risk Assessment, and Risk Control. And the key word in this slide's title is continuous. HIRARC is not a one-time exercise. It is a cycle that never ends. Let me walk you through the 4 steps. Step 1. Classify activities. Before you can identify hazards, you need to inventory everything that happens in your workplace. This includes routine tasks, the daily operations. Non-routine tasks, maintenance shutdowns, emergency procedures. And emergency scenarios, what happens if things go wrong? Every activity category must be documented. Step 2. Identify hazards. For each activity, you systematically look for hazards across all 5 DOSH categories: physical, chemical, biological, ergonomic, and psychosocial. I want to flag this. Inspectors consistently find that organizations miss the ergonomic and psychosocial categories. Repetitive strain, workplace stress, bullying, burnout. These are real occupational hazards with real health consequences. Don't neglect them. Step 3. Assess risk. You evaluate each identified hazard using the risk formula, likelihood multiplied by severity. You use the DOSH risk matrix to generate a baseline risk score. This tells you how urgently each hazard needs to be addressed. Step 4. Control risk. You implement the hierarchy of controls, which we'll cover in a moment, assign responsibility, and document timelines. The review triggers in the center of the diagram are important. You must review your HIRARC every 3 years at a minimum, or after any accident, process change, or new legislation. With OSHA 2022 now in force, many organizations needed an immediate HIRARC review. This is not bureaucracy. This is systematic protection.
The DOSH Risk Matrix is the standard tool for quantifying risk in Malaysian OSH practice. Let me walk you through how to use it. The matrix is a 5x5 grid. The vertical axis is likelihood, scored from 1 to 5. The horizontal axis is severity, also scored from 1 to 5. You multiply the 2 scores to get your risk rating. The color zones tell you what action is required. Green, low risk, scores 1 to 4, the risk is acceptable. No immediate action is needed, but you should monitor existing controls and review at the next scheduled cycle. Yellow, medium risk, scores 5 to 12, a planned approach is required. You must put temporary measures in place immediately while engineering more permanent solutions. The timeline is typically weeks to months. Red, high or intolerable risk, scores 15 to 25, this is critical. Work must not start or continue until high-level controls are implemented. If the risk cannot be reduced to an acceptable level through available controls, the work remains prohibited. Let me give you a practical example. A worker is operating an unguarded bench grinder. Likelihood of contact, 3. Severity of injury if contact occurs, 4. Risk score, 12. That's a medium risk. You immediately put a temporary control in place, perhaps stopping use of that particular grinder, and you order a proper guard to be fitted as a permanent engineering control. Now imagine the same grinder, but the guard was removed for maintenance last week and no one put it back. The grinder is being used by 5 different workers daily. Likelihood 5, severity 4, risk score 20. That's an intolerable risk. Work stops immediately. This matrix gives you a standardized, defensible basis for safety decisions. Learn it. Use it in your professional practice.
The hierarchy of controls is perhaps the single most important practical framework in OSH engineering. It tells you not just what types of controls exist, but which ones are most reliable and which ones to prioritize. The hierarchy is structured as an inverted pyramid, with the most effective controls at the top and the least effective at the bottom. Effectiveness decreases as you move down. And I want to be very clear about what effective means here. It means the control works regardless of human behavior. The best controls don't rely on workers doing the right thing every time. They make it physically impossible to do the wrong thing. At the top, elimination. Remove the hazard entirely. If you can redesign a construction process so that certain work is done on the ground instead of at height, you have eliminated the fall risk completely. This is the gold standard. Second, substitution. Replace the hazardous element with something safer. Switching from solvent-based paints, which emit toxic VOCs, to water-based paints is a substitution. The work still gets done, but the hazard is reduced. Third, engineering controls. Isolate people from the hazard through physical means. A soundproof enclosure around a noisy CNC machine. A guard on a rotating shaft. A ventilation system that removes toxic fumes. These work passively, they don't require workers to do anything differently. Fourth, administrative controls. Change how the work is done, through procedures, training, scheduling, and permit systems. Permit to work systems. Lockout tagout procedures. Job rotation to reduce ergonomic exposure. These are important but less reliable, because they depend on human compliance. Fifth, at the very bottom, PPE, personal protective equipment. Gloves, helmets, safety glasses, ear defenders. PPE is the last line of defense. It relies 100% on human compliance, the worker wearing it correctly, every time, for every exposure. It does nothing to eliminate or reduce the hazard itself. And here is the critical audit red flag from this slide. If your entire safety strategy for a known hazard consists of telling workers to wear PPE, without documenting why higher-level controls are not practicable, you will fail a DOSH inspection. PPE only is not an acceptable strategy unless you have genuinely explored and documented why elimination, substitution, and engineering controls are not feasible. Always start at the top of the hierarchy and work down. Only go lower when the upper tiers are genuinely not practicable.
Here is a finding that I want you to really sit with, because it has profound implications for how we approach safety. Research consistently shows that 80 to 90% of all workplace accidents are attributed to unsafe acts and human behavior, not to technical failures or equipment malfunction. Read that again. 8 out of 10 accidents happen because of what people do, not because of what machines do. Now, the instinctive response to this statistic is to blame workers. If people just followed the rules, accidents wouldn't happen. But this is precisely the wrong conclusion. Because if 80 to 90% of accidents are behavioral, and if lecturing people about following rules hasn't reduced that percentage, then the approach isn't working. What does work is understanding the ABC behavioral model. A stands for antecedents, the triggers. These are the environmental and organizational cues that set up a behavior. Safety signs on the wall. A toolbox talk at the start of the shift. The physical layout of the workstation. These antecedents influence what people do, but they are relatively weak predictors of behavior. B stands for behaviors, the observable act itself. In our example, an employee choosing to bypass a machine guard to save 30 seconds per cycle. C stands for consequences, what happens as a result. And here is the key insight. Consequences are far more powerful drivers of future behavior than antecedents. If the worker bypasses the guard and nothing bad happens, and they complete the job faster and the supervisor says nothing, the consequence reinforces the unsafe behavior. It will happen again. Conversely, if positive consequences consistently follow safe behavior, recognition, praise, bonus schemes linked to safety performance, safe behavior becomes the norm. This is the logic behind behavior-based safety programs. You don't just design a safe workplace. You design a culture in which safe behavior is consistently reinforced and unsafe behavior is consistently corrected. Hierarch establishes the baseline. BBS shapes the execution.
Where does your organization sit on the safety culture spectrum? This model gives you a framework to assess that and to understand what it takes to improve. There are 5 levels. Level 1, pathological. The mindset is evasion. Who cares as long as we're not caught? Safety is treated as an obstacle to production. Near-miss incidents are hidden. Accident statistics are manipulated. This is unfortunately more common than we'd like to believe, particularly in SMEs. Level 2, reactive. The mindset is damage control. Safety is a priority only after a major accident. This is the classic example of an organization that implements a new safety procedure only after someone dies. The Bright Sparklers factory was almost certainly at level 1 or 2. Level 3, calculative. The mindset is compliance. We have systems in place to manage all hazards. The methodology is hierarch, but it's done as a tick box exercise. The documents are filed. The meetings are held. But the culture is one of compliance rather than genuine commitment. Level 4, proactive. Safety leadership and workers begin to anticipate problems before they occur. Near misses are reported, investigated, and used as learning opportunities. The methodology shifts from reactive hierarch to active behavior-based safety. Level 5, generative. Safety has become an autonomous core value. Near misses are celebrated as learning opportunities rather than embarrassments. Safety is genuinely how the organization does business. Every employee at every level is an active participant in the safety culture. And notice the annotation on the slide. OSHA 2022 fines are specifically designed to force organizations out of levels 1 and 2. The RM 500,000 fine and personal director liability are not punitive for their own sake. They are designed to make it economically irrational to remain at the bottom of the maturity scale. Achieving level 5 requires merging engineering controls, the physical, technical solutions, with positive behavioral reinforcement. Neither alone is sufficient. Together, they create the conditions for genuine safety culture.
This visual perfectly illustrates a critical analytical distinction that is often missed in safety discussions. Total injuries and fatal risk are not the same thing. On the left side of the scale, services and manufacturing. These sectors generate the highest total number of injuries. Large workforces, high frequency of activity, many exposure events. But the individual injuries, while serious, are relatively lower severity on average. High frequency, lower severity. On the right side of the scale, construction. This sector generates far fewer total injuries than services and manufacturing. But it generates 88 fatalities, the highest of any sector, and roughly triple the national average fatality rate. Lower frequency, maximum severity. This is the fundamental distinction the risk formula captures. Risk equals likelihood consequence. High likelihood with moderate consequence can produce the same risk score as low likelihood with catastrophic consequence. But the management strategies are completely different. For services and manufacturing, the focus should be on frequency reduction, reducing the number of incidents through better process design, ergonomic improvements, and behavior-based safety. For construction, the focus must be on consequence reduction, because when incidents happen, they tend to kill people. Falls from height. Being struck by a crane load. Cave-ins. These events are relatively infrequent, but almost always catastrophic. The engineering controls and hierarchy of controls must be focused on ensuring that when something does go wrong, the consequences are survivable. As an engineer, this distinction will determine where you focus your safety investment. Apply the risk formula. Don't just count incidents. Weight them by severity. Your risk profile will tell you where to focus.
Beyond knowing which sectors are most dangerous, modern safety practice requires us to understand the mechanisms of injury, how injuries actually happen, so we can design targeted preventive interventions. Two mechanisms dominate the Malaysian construction fatality data. Gravity and elevation, falls from height. This is the primary fatal risk in construction globally, and Malaysia is no exception. A worker at height, without adequate fall protection, is always at risk. And when the fall occurs, the consequences are almost always severe or fatal. The engineering response to gravity risk is well established. Physical barriers at edges, guardrails, safety nets below work at height. Fall arrest harnesses as a last resort, and, most powerfully, prevention through design to eliminate work at height wherever possible by redesigning the construction sequence to allow prefabrication at ground level. Kinetic impact, being struck by moving objects or machinery. Cranes, forklifts, vehicle movements in congested construction sites. This risk category requires segregation of pedestrian and vehicle zones, clear sightlines, physical barriers, and strict permit systems governing the movement of heavy equipment. The note at the bottom of this slide is important. Modern safety reporting standards have shifted from simple permanent non-permanent disability tracking to precise injury type and body part classification. Why? Because sprained back and traumatic amputation are very different events requiring very different prevention strategies. Detailed data enables targeted intervention. As future engineers, when you review safety statistics, don't accept aggregated summaries. Ask for the mechanism breakdown. Ask for the body part data. The detail is where the actionable insight lives.
We've mentioned the SME underreporting problem multiple times. Now let's understand why it exists, because it matters for how we interpret all Malaysian safety statistics. The SME underreporting gap is driven by three self-reinforcing forces. Limited safety resources. Most SMEs don't have dedicated OSH personnel. The owner is often also the operations manager, the HR manager, the safety officer, and the finance director. There is no one whose job it is to file incident reports with DOSH. When an incident happens, the priority is getting the operation running again, not navigating regulatory reporting requirements. Production pressure. SMEs operate on thin margins. Every hour of production downtime costs money the company may not be able to afford. Reporting an incident means an investigation. An investigation means scrutiny. Scrutiny might mean an improvement order or a temporary shutdown. The financial incentive is to manage the incident internally, get the worker back on the job as quickly as possible, and not attract regulatory attention. Fear and weak culture. In many SME environments, particularly in sectors with a high proportion of migrant or informal workers, there is a genuine fear of reporting incidents. Workers may fear consequences, losing their job, having their immigration status questioned, being blamed for the accident. Without a culture of psychological safety, near misses and minor incidents simply go unreported. The consequence of all this underreporting is significant. When DOSH publishes injury statistics, those statistics systematically undercount the true scale of the problem. Policy decisions made on the basis of those statistics are built on incomplete data. The true national injury rate is likely much higher than official figures suggest. This is why Section 29A, mandating OSHC appointment in all workplaces with 5 or more employees, is such an important structural intervention. It doesn't just create safety personnel. It creates a point of accountability for reporting.
This slide draws a critical distinction that is often blurred in casual safety discussions. Occupational diseases and occupational accidents are fundamentally different in how they develop, how they are detected, and how they must be managed. Let me walk through the comparison table. Onset speed, accidents are instant, acute trauma from a single event. Occupational diseases develop slowly through chronic exposure over time. You don't get noise-induced hearing loss from one loud bang. It develops over years of continuous exposure to elevated noise levels. Detection window, accidents are visible immediately. By definition, you know when one has occurred. Occupational diseases have a delayed detection window. They often require specialized screening, audiometric testing, lung function tests, blood toxicology panels. Without systematic health surveillance, many cases go undetected for years. Primary challenge. For accidents, the challenge is severity management, preventing the injury from occurring, or reducing its severity through engineering controls and PPE. For occupational diseases, the challenge is the long latency and chronic underdetection. A worker developing silicosis may feel completely healthy for 15 or 20 years while the disease progresses silently. Primary example, fall from height or being struck by an object, classic acute accident mechanisms. Noise-induced hearing loss, the dominant occupational disease in Malaysia, accounting for 82.8% of all diagnosed occupational disease cases. The implications for OSH management are significant. Accident prevention and disease prevention require different monitoring systems. Accidents are detected through incident reporting. Diseases require regular, systematic health surveillance, periodic audiometric testing for noise-exposed workers, lung function testing for those in dusty environments, and so on. HIRARC must address both accident risk and disease risk. If your risk assessment only looks at acute injury hazards, you are missing a substantial portion of the occupational health burden.
This slide illustrates one of the most challenging aspects of occupational disease management, the latency blind spot. Look at the two timelines. The accident timeline is simple. Day 1, the event happens. Detection and reporting are immediate. The injury is visible, it is documented, and it enters the statistics on the day it occurs. The disease timeline is completely different. Year 1, the exposure begins. Perhaps a worker starts a job in a noisy environment, or begins working with chemicals that contain carcinogens, or takes on work that involves prolonged awkward postures. The disease process begins, but silently, with no symptoms, no reports, nothing visible. Years 2 through 9, the silent latency period. The worker continues to be exposed. The pathological process continues. But they feel fine. There is nothing to report. The annual safety statistics don't capture this ongoing harm because it is invisible. Year 10, detection. The audiometric test finally shows significant hearing loss. The chest X-ray reveals early fibrosis. The blood test shows elevated biomarkers of chemical exposure. Only at this point does the case enter the occupational disease statistics. What are the practical implications? First, today's occupational disease statistics are a lagged picture of exposures that happened years or decades ago. The people showing up in today's diagnosis data were exposed in the 2010s, perhaps earlier. Second, the workers in your workplace today who are exposed to noise, or chemicals, or ergonomic stressors, their disease burden will show up in the statistics in 2035 or 2040. Your actions today determine those statistics. Third, you cannot rely on symptoms to detect occupational disease. You must conduct systematic, periodic health surveillance, audiometric testing, spirometry, biological exposure monitoring to detect the disease early while intervention is still effective. The latency blind spot is real, it is structural, and it guarantees chronic underdetection unless you build proactive surveillance into your safety program. I want to revisit the concept of OSH as a cycle rather than a task, because this is a mental model that will serve you throughout your career. This diagram presents the 4 steps of the continuous risk management cycle with a central message that I want you to memorize. OSH is not a compliance checklist. It is a continuous risk management cycle. Let's go around the cycle. Step 1. Identify hazards. Proactively find potential dangers to safety and health. This is not a passive exercise, you have to go looking for hazards. Walk the work floor. Talk to workers. Review incident history. Use structured tools like Hierarch. Do not wait for someone to get hurt to tell you where the hazard is. Step 2. Assess risks. Evaluate the likelihood and severity of each identified hazard. Use the risk matrix. Prioritize your response based on the risk score. This step transforms your hazard inventory into an action priority list. Step 3. Implement control measures. Apply effective controls to eliminate or minimize risks, following the hierarchy of controls. Document what you've implemented, who is responsible, and when it must be reviewed. Step 4. Respond to emergencies. Execute planned procedures to manage critical incidents. This step recognizes that even excellent prevention does not guarantee zero accidents. When the unexpected happens, you must be ready. And then the cycle continues. After responding to an emergency, you return to hazard identification, because the emergency itself may have revealed new hazards, or may have indicated that existing controls were inadequate. The reason this is a cycle and not a linear process is that workplaces are not static. New processes are introduced. New chemicals are brought in. New workers join who need orientation. Regulations change. Equipment ages. The risk landscape is constantly evolving, and your safety management system must evolve with it. Build this cycle into your engineering mindset. Make it a habit, not a project.
The modern Malaysian OSHA framework is, in a very literal sense, an architectural response to historical failures. This slide shows you which specific historical failure each component of the modern framework was designed to address. Employee empowerment was missing before. Workers lacked the agency to stop disasters even when they could see them coming. At Bhopal, there are accounts of workers who knew something was dangerously wrong but had no power or protection to halt operations. The modern fix, the right to remove oneself from imminent danger under Section 26A, with full legal protection against termination, penalization, or wage docking. Mandated oversight was optional before. When safety oversight is optional, market pressures consistently drive it toward the minimum, or below. The modern fix: mandatory risk assessments under Section 18B and mandatory emergency preparedness plans. These are not recommendations. They are legal duties. Cultural accountability was absent before. Management could evade direct consequence for safety failures by hiding behind corporate structures. The RM 50,000 cap meant that fines were a manageable business expense. The modern fix, shared liability. Directors face personal, joint, and several liability for corporate OSHA violations. Drastically higher penalties, up to RM 500,000. The legal accountability now follows the management authority. If you have the power to make safety decisions, you now bear the legal consequences of those decisions. Each pillar of the modern framework is a direct response to a documented historical failure. The law has learned from tragedy. The question is whether we, as individual engineers and as organizations, will learn from the law.
This flowchart makes the Section 29A compliance logic crystal clear, and I recommend you use this exact decision tree when advising any organization on their OSHA compliance status. Does your workplace have 5 or more employees? If no, standard compliance duties apply under OSHA. You still need to ensure a safe workplace, but the specific OSHA requirement doesn't trigger below 5 employees. If yes, move to the second question. Is a safety and health officer already legally required at your workplace? If yes to SHO requirement, maintain the SHO. You're compliant on this dimension. Your workplace is large or high risk enough that the existing SHO mandate covers you. If no to SHO requirement, this is where the new rule activates. You have 5 or more employees, you're not big enough or high risk enough to require a full-time SHO, but you do need safety oversight. The mandatory requirement is appoint an OSHC, an Occupational Safety and Health Coordinator. The OSH role is designed for this middle tier. The qualification is less demanding than the full SHO certification, but it is still a formal, recognized qualification. The OSHC must support management in identifying hazards, implementing controls, and maintaining OS records. Non-compliance, RM 50,000 fine or imprisonment for up to 6 months. I want to be clear about why this matters. Most businesses in Malaysia, 97.4% of industries are SMEs. Most of them have fewer employees than the SHO threshold. Before Section 29A, they had no mandatory safety oversight at all. Now they do. This is the single most important practical change in OSHA 2022 for the majority of Malaysian employers. If you join or start an SME with 5 or more employees, this is one of your first compliance checkboxes.
One of the most important practical principles established by the 2024 OSHA framework is the concept that liability follows control. If you control the work environment, you bear responsibility for its safety, regardless of what your contracts say. The diagram shows 4 categories of risk creators, all converging on the central concept of liability. Directors and management, personally liable for corporate violations. Under the joint and several liability provisions of OSHA 2022, individual directors can now be prosecuted personally for safety breaches, not just the company. If you are a director, your personal assets are potentially at risk. Principal company, responsible for site safety regardless of employment contracts. If a main contractor brings subcontractors onto a site, the principal company cannot contract away its safety obligations. Even if a subcontractor employs the workers, the principal company bears responsibility for the safety of the overall site. Contractors and subcontractors, accountable to the principal. They carry their own safety obligations, but they are also subordinate to the principal company's safety requirements.
Substandard safety performance by a subcontractor is a problem for both the subcontractor and the principal. Direct employers and self-employed. The base operational duty. If you employ workers directly, you bear the fundamental duty of care that is the foundation of OSHA. The critical statement at the bottom of this slide, the 2024 framework enforces a shared liability model. You cannot contract away your safety responsibilities. This is a paradigm shift that will affect how contracts are drafted, how supply chains are managed, and how engineering oversight is exercised. If you are the principal engineer on a project and subcontractors on your site are operating unsafely, you now have both a professional obligation and a legal liability to intervene.
Section 26A of OSHA 2022, the right to refuse, is one of the most powerful and personally relevant provisions in the new framework for you as a future engineering professional. Here is the legal logic. If two conditions are both met simultaneously, first, an imminent, serious risk to health or safety exists in the workplace, and second, the employer fails to take action to address that risk, then legal protection is activated. With that protection active, an employee legally removes themselves from the dangerous situation, and they cannot be penalized in any way for doing so. Total protection from termination, penalization, or wage docking. This right exists in response to one of the key lessons from historical disasters like Bhopal. Workers knew things were wrong, but they had no legal power to act on that knowledge. They were economically coerced into accepting dangerous conditions. Section 26A eliminates that coercion. Your supervisor instructs you to... Now, how does this apply to you as a graduate engineer? Consider a scenario. You are a junior site engineer. Your supervisor instructs you to proceed with a task, perhaps working in a confined space or conducting an electrical test without the required permits and safety checks in place. You assess the situation and believe there is an imminent risk of serious injury. Under Section 26A, you have the right to refuse. And if your employer penalizes you for exercising that right, they are breaking the law. You also have the professional obligation under the Beam Code to refuse. And you have the moral obligation to refuse. These three obligations, legal, professional, and moral, align perfectly in this situation. Know your rights. Know your obligations. Do not allow yourself to be coerced into accepting unsafe work conditions, regardless of the pressure.
As we approach the final section of today's lecture, I want to revisit the philosophical foundation of modern OSH practice because it captures something that goes beyond legal compliance. This inverted pyramid represents the evolution of how we think about preventing harm in the workplace. At the top, the most powerful tier, prevention through design, or PTD. The philosophy is to eliminate hazards before the blueprint is even drawn, before the factory is built, before the process is commissioned, before the equipment is installed. If you can design the hazard out of existence at the conceptual stage, nothing that happens in operation can create harm from a hazard that doesn't exist. PTD challenges engineers to think about safety not just during the construction or operation phase, but during the design phase, where the leverage to eliminate hazards is greatest and the cost of doing so is lowest. In the middle tier, engineering controls and fail-safes. Physical systems that isolate people from the hazard. Enclosures.
Guards. Ventilation. These are built into the physical environment and work passively, without requiring worker action or compliance. At the narrow bottom, the last resort. Personal protective equipment. The absolute last line of defense. Not the primary strategy. This pyramid intentionally shows PPE as the smallest tier, not because it's unimportant, but because it should be the last resort, invoked only when higher tier controls are genuinely not practicable. The statement at the bottom of this slide is the philosophical manifesto of modern OSH. Modern safety management demands fail-safe systems, prioritizing engineered safety over human reliability. This is the standard. Not, we told them to be careful. Not, they should have worn their PPE. Engineered safety. Systems that work regardless of human error. That is the professional obligation of every engineer in designing, building, or managing a workplace.
This final synthesis diagram captures the most fundamental principle of the modern OSHA framework. Those who create the risk are responsible for managing the risk. This is the core of the self-regulation philosophy. In the old command and control model, safety responsibility was diffuse. Government inspectors enforced compliance, and employers responded to enforcement. In the modern model, responsibility is clear. Whoever creates the risk owns it. Look at the three principles that underpin this ecosystem. Integration. No distinction between factory, office, or WFH. The risk doesn't care where it exists. The law follows the risk wherever it manifests. Proactivity. HIRC drives action, not government checklists. You don't wait for the inspector to tell you what's wrong. You find it and fix it yourself. The analytical tools are HIRC, the risk matrix, and the hierarchy of controls.